So I'm going to be discussing a project that we've been working on where we've tried to look into patient prediction and see whether we could identify a smallish, say around 50, predictors that could be used for any outcome. So before I actually dive into the project, I just want to highlight this is very much a team effort. And a shout out to Chung Soo, who actually managed to take all of our individual photos and put us into a hypothetical if we worked in the same office photo. So why is it that we're interested in coming up with this constrained set of predictors? Well, some of you may have come across websites like MDCalc, where you can actually go onto there, you can pick a model you're interested in, you can fill out things like your age, your sex, and a few questions about yourself. Press enter and it will tell you your risk of a certain outcome. But what you find with these is this will give you a risk of one outcome. If you wanted to see your risk of another outcome, you have to find another form, fill out a few more questions, press the button, and you get that risk. But this doesn't scale up. If you wanted to know what's my risk of actually 100 different outcomes or 1,000 different outcomes, and in OHDSI, we like to do things at scale, maybe even 1 million outcomes, you're going to have to fill out a lot of different questions, and it's going to be a lot of forms. So our idea is, can we find some predictors that are just generally good for any prediction task? And that way we could have one form that you fill out, press enter, and it could tell you a risk of many different predictions. So the methodology, there's quite a lot to it. And if you want to hear more detail, I welcome you to come find me at poster 505. But just to give you a brief overview, we ended up doing a very, very large scale characterization. So what we did is we looked at lots of different prediction tasks. And within each prediction task, we looked at what drugs and conditions were recorded in the year prior to index. And then we looked at which of these drugs and conditions were associated to developing an outcome in the future. Because for prediction, the good predictors are generally the things that are strongly associated to having the outcome in the future. So we looked at, let's find these drugs and conditions that are associated that should be good predictors for an outcome. But let's not do this for one task, let's do this for 65,000 prediction tasks. So we looked at many, many different at-risk populations, many, many different outcomes within lots of claims and EHR data sets. And we counted out of these 65,000 plus prediction tasks, how often each drug and each condition was associated to developing the outcome in the future. And we ordered these drugs and conditions in descending order based on how often they were found to be associated. So these conditions and drugs that were in the top 1,500, these are the things that generally, over lots of different prediction tasks, are good predictors. And we reviewed them and we found 67 different topics, things like hypertension and heart failure, that we then created phenotypes for in the standard OHDSI process. So this is our list. I'm sure some of you may not be able to read if you're at the back, but there's a list online, and also I'm happy to explain them more at the poster. But effectively, there's 3 takeaways from our 67 predictors that we found, or candidate predictors. One thing I want to highlight is that they're available in the phenotype library, so you can actually get them from an R package now that Galpham is maintaining. And then secondly, these predictors, they actually are quite diverse. So we're seeing that we actually found things that cover lots of different disorders. So that's good. And secondly, they're things that are commonly recorded in our data, and often you'll find these in existing prediction models. So really, we didn't find anything new. We just found a set of 67 predictors that you would expect probably are going to be good predictors in models. The next thing we wanted to do, though, was seeing how well did these do. So our previous approach of doing prediction in OHDSI is the kitchen sink approach. You use any drug, any condition that were recorded in the prior year to see if you can put them as candidate predictors plus age and sex, and then you try and develop a model with those. So this is what we've called our best case logistic regression. Throw everything in there and see how well we do, no constraint. And then we've got our models that we develop using our constrained set of predictors, the 67 predictors that we just identified plus age and sex. So these are our constrained models. And then we also decided, well, we'll actually look at some prediction tasks where we have existing models, and we can see if there's how the existing models do as well. So the example I'm showing you here is the 1-year risk of mortality. And in that prediction task, Charlson Comorbidity Index is a common one, so we put that in. So there's a plot here. This is just one example, so one prediction task, but if you want to see more, come find me at my poster. The first row here is the best case. This is the unconstrained. So this is a model where we've got tens of thousands of predictors that we could have in that model. to predict mortality in the next year. The second one is just age and sex only predictors in the model. The third and fourth row, this is the constrained model. So this is when we're just using our 67 predictors we just found, plus age and sex. And then the bottom one is the Charles and comorbidity. So this is the existing model for this task. And each column here is a different database. And the number you find here is the AUC. So this is a measure of how well the model does in terms of discrimination. The closer that is to 100, the better. So the further they are to the right, the better these dots are. And what we see in this prediction task is that our constrained models, so our models that use only 67 predictors plus age and sex, were actually doing as well or better than the model that was using tens of thousands of predictors as candidates predictors. So this is actually very promising. We saw this result across all these different databases. So for this prediction task, our constrained set of predictors actually did very, very well. And it does seem like you can come up with a constrained set of predictors that should do well. But we didn't just do it for this prediction task. We actually have this for many different prediction tasks. And as I said, find me the poster if you want to see more results. So if this has made you interested, we actually, in the OHDSI style, we didn't stop there. We actually have created a website using these 67 predictors that you can actually go to. You can fill out one form, put in your age, your sex, your 67 predictors, whether you have them or not in the prior year, and it will tell you your risk of not one, not two, but over 100 different outcomes. So I hope you enjoy the website. Thanks for listening.